Hello everybody, this is our first flipped video of the year. Super excited to get this underway. Just to catch up on where this is starting in your workbooks, this is on page 11. In class, for most sections today, we made it up to this example right here on given a mapping. If you did not get this far in your class, maybe you were just missing this one, from here up is posted as a PDF right above where this video was, so you can catch up on the rest of the notes. Tonight's flipped homework is picking up with number 4, which is the launch of the continuous part of the notes. Number 4 is the last discrete example. Discrete meaning the maps, the tables, the ordered pairs, because those are countable. Even though this is on a coordinate plane, these are countable points. There's 1, 2, 3, 4, 5, 6 ordered pairs. So if you want to make a quick note, this is discrete because it's ordered pairs. And to approach it, we're actually going to get a list of ordered pairs off to the side. So we have points A, B, C, D, E, F. Yep. So let's make a list. A, B, C, D, E, and F. Remember, to get ordered pairs, we always start at 0, 0. We move left and right first, and then up and down. So if I'm starting at 0, 0, to get to point A, which is right there, to get to point 0, I don't want to get to point A, I don't want to move left or right at all. So that's going to be 0, comma something. So don't move left or right, just go straight up. 1, 2, 3, 4. So A is 0, comma 4. If you're confident to get all of your ordered pairs, you can actually jump the video ahead a couple seconds and compare your list of ordered pairs. You can press the space bar to pause, get your list, and then compare, or keep listening and follow along as I get the rest of the ordered pairs. Coming back to 0, 0, I look with my eyes and I see that point B is to the left. So I'm going to go left. 1, 2, 3, 4, 5, 6. So that means my x value is negative 6. Notice though, I'm actually at the point. I don't want to move up or down at all. So that's going to be negative 6 because I went left 6, but 0 for a y value because we didn't move up or down. We wanted to stay right there. Coming back to 0, 0, I see with my eyes that the ordered pair named C is left and down. So I'm going to go left. 1, 2, 3, 4. So negative 4. Down 1, 2, 3, 4. So that's going to be negative 4, negative 4. Coming back to 0, 0. With my eyes, I see that point D is left and up. Left. 1, 2. Up. 1, 2, 3, 4, 5, 6. So negative 2, comma 6. Back to 0, 0. Notice this process just repeats each time. Back to 0, 0. I find point E with my eyes. It is right and then up. So I go right. 1, 2, 3, 4, 5. So that was right 5, up 2. 1, 2. So 5, comma 2. Back to 0, 0. Last but not least, point F is right and down, so I go right 1, 2, down 1, 2, 3, 4. So 2, comma, negative 4. Now that I have my list of ordered pairs, we are right back to what we were doing in the class notes. For our domain, we can, let me see here. We actually cross off, please, the interval for each of these. Interval is saved for when we have a continuous relation or function. So where it says domain is in set notation and range is in set notation, we're just going to write it as our list like we did in class. Domain will be the set of all x values, range is the set of all y values. So we're just going to straight up list the x values. And what's nice is that, see how we wrote our ordered pairs as a vertical list? That means that for my x values, you don't have to circle them if you want to look real quick. All of these are my x values. And then all of these are my y values. So if I look at my x values, my smallest x value, if I'm going from negative to positive, is -6. So I'm going to just gently cross off -6, and then I'm going to say -6, comma, and then it's going to be -4, -2, 0, 2, and then 5. Please press the space bar right now and list the range by yourself. When you're ready, press space again and it'll play, and then we'll check answers for the range. So for the range, I'll start with my curly bracket again. Looking for the smallest value, it's going to be -4. I see that I have two -4s, but we only write one of them, so you can actually cross out both of those -4s. Next comes 0, and then 2, 4, 6, and that's it. Is this a function? So there's two ways we can look at this. We do have this list of ordered pairs, and because I only lightly cross them out, I can still see my x values. Remember from class that if there are no repeating x values, we're good to go automatically. So 2, 5, -2, -4, -6, 0. So right away I can say yes, because each input, or you can say x value, whichever makes you happy, is sent to 1 and only 1 value, only one y value. Remember, we can only make this statement when it's discrete, when it's countable. Past this example, we no longer will be able to use this statement. So let's actually get into our first continuous example of the notes. This is a continuous example because it's a graph. Remember, lines are made up of so many points graphed so close together you can't see the space in between the points. So this is not countable. Domain and range for continuous graphs is something that's really easy to see if we use our pencil to help us out. So I'm going to pause real quick so I can kind of draw a vertical line. I'll be right back. Hold on, I'm going to pause my video, but I'll be back in a second. And I'm back. I remembered how to get to my lines. So for me, my pencil is going to be represented by this giant thick red line. So take your pencil, please, and put it flat on the paper just as you see it, like I have. And now I can move this like I was moving a pencil on my paper. So for domain, we need to remember that no matter what, domain is always x and range is y. Pick up your pencil for a second. I'm going to leave mine right there, but let's just agree on what the set notation is going to be. From class, we talked about how no matter what, it's going to be the curly bracket with an x. This means such that, leave a space because you're going to fill in a number. We don't know yet what number it's going to be. The middle never changes. X is going to be greater than something and less than something. This, what you see in blue, will always be the setup for set notation. Our job now is to use our pencil, for me it's this red line, to figure out what number goes here and here. So for domain, if you want to make a little note, I'm going to put L, comma, R. And what this is going to help me remember is that for the domain, first I'm going to come in from the left side. This is the left side of the graph. I'm going to come in from the left. And I'm going to keep coming in from the left with my pencil. So if you're just watching this, I won't be able to see you, but you know who you are. Pick up your pencil, put it flat on the paper like this, and now come in from the left with me, just like you see me doing on the screen. I come in from the left, and I keep coming in from the left. I'm going to stop when I hit the graph. Right there, I hit the graph. And I ask myself, where am I on the x-axis? On the x-axis, I am at 1. So 1 goes right here. Then I take my pencil, and I take it off the graph, and I'm going to move to the right side. And now I'm going to come in from the right side, and the same principle applies. Stop when you hit your graph. Right there, I hit the graph. At first, when I ask myself, where am I on the x-axis, it kind of looks like I'm at 5, because this is where 5 is, right there. But then I look and I see that I hit an arrow. I'm going to move my pencil out of the way for a second. Remember that an arrow means that this line actually keeps going forever and ever and ever and ever and ever. To the right, forever and ever, is positive infinity. So positive infinity goes right there. I've successfully filled in my 2 values. I'm just going to draw that a little neater. The only thing I have to ask myself is, do I have any open or closed circles? Because that would adjust my inequality signs. So remember, we can never equal infinity. So that says so. Let me rewrite that. We can never equal infinity, so there's never going to be a line underneath the inequality sign. I'm sorry for the gaps in the letters. I'm not sure why it's doing that to me. Meaning, whenever there's infinity there, you're never going to say it's equal, because it keeps going forever and ever. But when I look at this side where 1 is, I know you don't see a closed dot, but because you don't see an open circle would look something like that. It's automatically closed because there is a point right there. So that means that this inequality sign right here does get a line underneath. And if we were to read this from the middle, we're saying x is greater than or equal to 1 and less than infinity. For the integral notation, it's super easy because we're actually going to pull our 2 values. It's going to be 1, comma, infinity. And then we just have to decide bracket or parenthesis. Well, from last year, I hope we remember that if it's equal to, it gets a bracket. We can never equal infinity. We just talked about that. So this is going to get a parenthesis, and I'm all done. Let's move on to the range. Looking at your setup, everything in blue is going to be the same for set notation, except with a y. So leave a space. We're going to say y is greater than a value and less than a value. So notice, oops, I left a solid amount of space right here and right here to write something in, but I don't really like that curly bracket, so I'm going to rewrite it. Okay, now just like we had keywords with left, the L and the R for left and right, come in from the left, then come in from the right. For the range, we're going to write B, comma, T. To remind us that for range, first we come in from the bottom, then we come in from the top. To do that, please take your pencil and put it horizontally, sideways, like that. So just like these letters stand for, bottom and top, I'm now going to come in from the bottom. This is the bottom, and then this would be the top. Come in from the bottom. So coming in from the bottom, I'm going to stop when I hit the graph, and I hit the graph right there. And now I ask myself, where am I on the y-axis? Because now we're talking about the range. I'm going to pause for a second so you can think about that. Where am I on the y-axis? When I look to see where am I on the y-axis, here's my y-axis. I'm going to highlight it real quick. This is what I'm looking at. So on my y-axis, I am at 0. Some of us might be saying, but wait, that's not 0, that's 1. But remember, 1, if I move my pencil out of the way for a second, ask yourself, which axis is 1 at? 1 is on the x-axis. Another way of looking at it, if I wrote this as an ordered pair, that's 1, 0. Remember, for the range, we are looking at y values. The y value here is 0. So if I were just to use my pencil, though, to figure that out, let me get rid of that point so it's not in the way. Just asking myself using my pencil, where am I on the y-axis? As long as I mentally just pay attention to this axis, I'll be fine. Because we're definitely not at 1 on the y-axis. We're at 0. Now, we accomplished half of it. We got 0. Now, to get this value, we're going to come in T for the top. Come in from the top. So bring your pencil up here, and just a little longer. Oops. Now we're going to come in from the top. I stop when I hit my graph. Technically, there we go. So when I hit my graph, it looks for a second like it could be 2. But once again, I hit this arrow, so that means positive infinity. The last thing I need to ask myself is, do I need any lines underneath my inequality symbols? Once again, infinity can't equal infinity, so no line underneath. 0 for this value here. Again, this is a solid dot, so I would have a line underneath that inequality. For the interval notation, we simply pull these two values. So 0, infinity. It is a solid dot there, so that this side gets a bracket. Infinity always gets a parenthesis, and we are done. For a continuous graph, to decide if it is a function, we use the, I'm all set with my pencil, so I will delete it, vertical line test. So, vertical line test says I should be able to draw a vertical line anywhere I want through, I was drawing a funky pink one, but maybe I just used purple. I should be able to draw a vertical line anywhere through this graph, and it's only going to hit once. If I look, no matter where I drew this vertical line, so maybe you drew yours over here, or somebody draws it over here, it's only hitting my graph once. I actually cannot draw a vertical line that would hit twice. So we say, is it a function? Yes, because graph passes VLT. And that's it, passes vertical line test. Moving on to our next example. For all of these graphs, 6 through 11, what we just did on number 5, it never ever changes. So let me see what we're at for time. 19 minutes. So we have time to do one more example, and then it would be amazing if you guys could work on, in pencil, just in case we need to update or change anything tomorrow during our debrief, if you could work on number 7, number 8, and number 9. That would be fantastic if you could take a couple minutes after the video to try those. But let's wrap up these flips notes with number 6. So let's get ourselves ready to go. Domain is all about X, range is all about Y. My notation for set notation is always the same. Curly bracket X with a bar, leave some space. I have my middle part right there, and then I end it with a curly bracket, again leaving space. Remember, we read this from the middle. X is going to be greater than something and less than something. Let's get our pencil on the paper. So I'll get my pencil. Ready to go. That key assistant you could put right here for domain, L, R. That helps me remember that I'm going to come in from the left. So I take my pencil and I put it on my paper like so, vertically, and I'm going to come in from the left and I'm going to stop when I hit the graph. So I keep coming, I keep coming, I keep coming, and I stop right there. I ask myself, where am I on the x-axis? I am at -4. So I put -4. I could also decide at the same time, do I need a line underneath the inequality sign? I do not see an open hole. Again, just for emphasis, an open hole would literally look like an open hole on the graph. So that means that this is a solid dot, so this gets a line underneath. We are halfway done with this. I just successfully came in from the left. Now I need to come in from the right. So I take my pencil and I move it over here. Coming in from the right, I'm going to stop when I hit the graph. Hit the graph right there. Looks like it could be 2, but I'm like, no, 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 because I see that I have these arrows. I know there's 2 arrows, but even 1 arrow would be enough to tell me that this is going to go towards infinity, positive infinity, forever and ever and ever. Remember, we can't equal infinity, so this will not get a line underneath. So this is all done. For the interval notation, we're going to pull our 2 values like so. Or equal to means this gets a bracket. Can't equal infinity, this gets a parenthesis. We've taken care of domain. Now we're going to work on the range. My hint letters that you can always write for yourself whenever you see range, B, comma, T. You're going to come in from the bottom and then the top. I would challenge you to pause the video, go look at number 5, and see if you can do range all by yourself. At any point, pause and try to finish it before I say it, and then see if we match. For those of you who want to wait to try it on your own for numbers 7, 8, and 9, if you have a couple minutes after, no problem at all. Stay with me. So let's get our setup. I'm going to put my little curly bracket with a Y, leave a space, right down the middle, and end it with another curly bracket. Reading from the middle, we're going to be saying now that the Y values are greater than something and less than something. Because I'm now coming in from the bottom and then the top, I'm going to turn my pencil sideways. So it's now horizontal. And I'm going to do exactly what my little reminder tells me to do first. I'm going to come in from the bottom. So coming in from the bottom, I'm going to stop when I hit the graph. And there it is. Now at first, it could look to me like it's at -6. But I see this arrow. Now, really have an open mind about what I'm about to say. Remember that for the Y values, we are only concerned with this axis right here that goes up and down. I know mine looks a little sideways. Let me see if I can straighten that out. Good. The Y values. My only option for the Y-axis is up or down. So, even though it looks, I'm going to use my purple. No, I'm going to use green. Even though it looks like this arrow is going to the right forever and ever and ever, really ask yourself, if I'm talking about left and right, is that X values or Y values? Well, left and right, that belongs to domain. So don't be fooled, because this is actually going to be negative infinity. And the reason is that even though this looks like it's going right, it technically is, but think about what's happening. I'm going to draw over these numbers just for a second. As this goes right forever and ever and ever, as it goes right forever and ever and ever, the y values are still decreasing. Notice that. It's going right, I agree. So as your x values get positive, your y values continue to get more negative forever and ever and ever. So that's why we're putting negative infinity right there. And we can talk more about this during the debrief also if you still have questions. Or shoot me a remind. We're halfway done with the range. Now we're going to come in from the top. So coming in from the top, I'm going to stop when I hit my graph. Once again, at first I could say, ooh, 4. 4 is my answer. But check it out. We hit an arrow for a second time. When I hit an arrow coming in from the top, it means that this is going to be positive infinity. So my range is y is greater than or equal to negative infinity and less than infinity. For my interval notation, I'm going to pull the negative infinity, comma infinity. We can't equal infinity ever, and so it's going to be parenthesis, parenthesis, and I'm done. We are all set with using our pencil on the graph, so I'm going to delete mine. Our last piece of question, because there were 5 parts. The last part is it a function? For continuous graphs, we use our vertical line test. If you can draw it so it fails, do that. So what I mean is sometimes people will do this first. They'll draw a vertical line here. That would technically pass. That only crosses once. But if I draw my vertical line right here, 1, 2, it makes this one irrelevant. Doesn't matter. If you have the ability to draw it so it fails, it fails. So, is it a function? No. Fails VLT, crosses twice. And we're done with number 6. If you have a little bit of time to practice what we just did while it's fresh in your brain, and you could even just do one more, please work on number 7, 8, or 9. If you have the ability to try all 3, that would be amazing. Just make sure you do it in pencil so we can adjust or update during tomorrow's debrief. This has been a great first video with you guys. Shoot me any questions on Remind. Can't wait to see you tomorrow. Have a good night.